Well, hello everybody. Good morning, afternoon, evening, good night, I suppose, wherever you are in some time zone in the world. Thanks for joining us live here today for Serverless Office Hours. We are streaming on the AWS Twitch channel, so welcome if you're joining us from there. We're also on the YouTube Serverless Land channel and also via LinkedIn Live. My name's Julian Wood. I'm a developer advocate for serverless here at AWS, and I'm super duper happy to have the one and only Jason Hunter, who's a principal solutions architect for Amazon DynamoDB. Welcome to Serverless Office Hours.
Thank you. Great to be here. Oh, I don't hear you. I don't hear you.
Hello, hello. Does that work now?
I hear you now.
Gremlins in the system. We're starting with gremlins. Isn't that a good start? Well, welcome, Jason. I'm not sure if you heard that, but yes. How did you come to AWS and your background with DynamoDB?
All right. I've been doing NoSQL databases. DynamoDB is a NoSQL database for about 20 years now. From the first time I encountered one where I loaded some data into a non-relational database and was able to get really fast answers without having to do all that relational schema design up front. And I remember staring at the wall thinking this changes everything. And at the time we didn't even have the name. We tried to think of the name, well, non-relational? Well, you can't define something by what it's not, but I was wrong. I mean, you can. We called it NoSQL. And so I've been doing that, and I came to DynamoDB focus a couple of years ago. And it's, I did a lot of due diligence before joining the team. I thought it was a really cool database, very innovative to be so cloud native. And so it's been really an enjoyable time here.
Cool, excellent. Yeah, it's actually funny enough. It's one of my sort of bugbears as well with the whole sort of moniker of serverless. It's like you're telling us what it's less, but what is it more of? And I have been known to make the joke about NoSQL. Like, so it's NoSQL. What is it then? You're not telling me what it is. You're telling me what it's not. That doesn't always help me. But anyway,
it's definitely not a server calling SQL. That's what we know today.
Yeah, exactly. So today we're all talking about servers calling SQL. That's going to be the complicated thing. So yeah, just before we get back to Jason and some more awesome DynamoDB stuff, just looking back in the last week of serverless here at AWS. Last week in Serverless Office Hours, we had Mehmet Nuridivechi, who was talking all about Lambda testing with remote invoke. This is a functionality of SAM. You don't have to be using the SAM framework. You can just use it to remote invoke any Lambda function. Whole bunch of cool information on debugging he shared and testing and how to generate events and how to pipe all cool commands together. I was inspired and surprised at how much Mehmet was able to cover. So that was super good. So that's on Serverless Land YouTube channel, along with all our previous Serverless Office Hours episodes. In terms of what's new on AWS, well, Lambda's got two interesting things. First of all, Lambda and Event Bridge pipes, and if you're not actually aware, under the hood, it's actually using the same Lambda event source mapping to use that. And now it's actually supports some enhanced filtering, which is really good. You can use much bigger filters, bigger numbers, but the really cool thing is actually suffix matching. So this means if you've got things coming in that need to match for PDF or need to match for .text, you can use that enhanced filtering in the Lambda event source mappings and also the managed part of that, the Event Bridge pipes. So yeah, super useful for your distributed applications that need to send events all over the place. Any more filtering is always going to be useful. And of course, that's also helpful for reducing costs, because if you are using Lambda, you're not then pulling a whole bunch of say files from S3, for example, and then ignoring all the text files and only processing the PDFs. Your Lambda invokes are still going to have to do that processing. Now you just set that up in the filtering, and you only get the records that you need. So super helpful. The simplifying .NET 6 Lambda functions, that's just some helpful tooling that can also help you with your .NET world. I noticed down, since we are talking Dynamo, a few weeks ago, DynamoDB came out with some cool things like the .NET distributed cache provider for Dynamo. So this is when you're using .NET and you can use that use Dynamo directly as a backend cache. And yes, also DynamoDB local. Jason, can you tell us anything about that while you're on the spot?
Well, DynamoDB local is what you use when you want to do sort of testing, you're offline, or just not use the cloud services. This one moved it into the Jakarta namespace, which has been something people have asked for.
Cool, excellent. Thank you very much. And in terms of serverless blogs, well, Gregor Hopper, the one and only Gregor, Enterprise Architectural Patterns, Gregor has done a really cool post all about event publishing with EventBridge pipes and talking all about how to use the managed service rather than your own code. And then in case you missed it, Ben, my colleague, has put together, basically, in case you missed it, for Q2 2023, all the releases, all the videos, all the blogs, all the code samples, snippets, everything, huge amount of stuff that's going on, and one easy blog post to read all about that as well. And then also just in the Lambda world, useful functionality detecting and stopping recursive loops in Lambda functions. This is primarily initially done for S3 and, sorry, not S3, is done for SQS and SNS. So if you are using SQS and SNS as a trigger to invoke your Lambda function, and then you write that data back to SNS and SQS, it's going to call a recursive loop. Well, now we're going to be able to check that out and stop that after 16 loops. And as Velson4 says, thanks for joining us via Twitch. Yes, less mental stress and less stress on your wallet as well, which is also one of the helpful things. EDA Day in Nashville, Event-Driven Architectures Day, 26th of October in Nashville. Get your tickets before they sell out. It's going to be super, super helpful. Lots of event-driven things. If you're listening to Werner's keynote from reInvent, Event-Driven Architectures was really the crux of that keynote, and this is going to explore even more of those with some top talks and workshops. So yeah, Nashville, 26th of October, will be super cool to see you there. The Serverless Land, which is all things to do with serverless, has a learning page which has now been updated. Lots of guides and workshops and migration bits of information. It's all based on a skill level. So if you're getting into new things with serverless or you're advanced, there's going to be something to find over there. And we've got more guides even planned in the future. So maybe mark that, can be super useful. I only need to punt my own kind of things. I've done a video series on Lambda fundamentals, literally starting at the very beginning of what is serverless and what is Lambda and going through use cases and how to build them. So if you are scratching your head wondering where to get started, hopefully that will be helpful for you. So that's looking back over the past week, but this week we are talking about DynamoDB global tables. So Jason, just sort of briefly over to you. DynamoDB tables, what are they?
What are DynamoDB tables?
Well, global tables and global tables, yeah.
Right. And from this on, now I could talk for an hour. So it's tough when
just before you pause there, because I know that we could go on for hours. Seeing Dynamo is one of our top topics. Is we are also live, remember? So please send us your questions, your comments via the chat on whichever platform you're with. Hopefully generally about DynamoDB, but anything to do with serverless, and yeah, we'll hopefully be able to get to them and help you out with your serverless development. So Jason, back to you.
Right. One of the challenges here is I'm talking to an audience I can't see. And I'm having to guess and assume how much expertise you have with global tables, with DynamoDB inherently. DynamoDB global tables are a capability where you can have data replicated across regions automatically using DynamoDB. So instead of having your data in one region, where it's still across availability zones, still in 3AZs for durability there, and you get 4 nines SLA in one region, with global tables, it auto-replicates to 2 or more regions, and as a result, you can have a series of advantages. You see what people are saying. So one of the advantages you would have is you would be able to have reads closer to your end users, right? So if I have everything in Virginia and I have someone in Europe, they're not going to be able to get the data as quickly as if I could put a copy of their data in Europe. So maybe I'll replicate the data to a region nearby to the end user. Also, maybe I want faster writes. Maybe I want the end users to be able to write and be done writing more quickly. So therefore, I need to have a copy of the data that they can write to, a copy of the table in the remote region for them to write to. Or maybe I want to have more high availability disaster recovery options where I want to say, even if a region has some issue, I need to move out of that region. It doesn't necessarily mean the DynamoDB issue, but something in that region that's not right. Maybe I deployed wrong, but I need to be able to move my stack to another region. I want DynamoDB to have a copy of my data in that other region ready to go immediately upon me evacuating one region, moving to another one. So those are the big things. And it's kind of distinct in that it's active-active. So it's not the typical you get with a relational database where you have a primary and a replica. You can write to either one. And because DynamoDB is a item-oriented NoSQL database, key value, you can write that item, you can write an item, and they'll crisscross cross region that way, which allows me to, for example, have the rights in Europe for some data and in US for some.
That's an awesome look at all the sort of use cases. Just to pick up on one of the first ones, I mean, DynamoDB is pretty resilient where it is in a single region. This is a pretty foundational service to AWS.
Right.
In fact, a lot of AWS and a lot of Amazon.com runs on DynamoDB. So it's not as though we need to have global tables for just for a resilience point of view. It can add some more resilience across regions. How would people think about when they need to expand to that additional region, purely from an availability and an uptime point of view?
Yeah, you have an SLA with DynamoDB in a single region of 4 nines, which is great for you not having to do any of the ops work. If you do global tables, it's 5 nines. So with that, you get a 5 nines, again, without you doing the ops work. The global table replication internals handle the replication for you. And so a lot of times people come to global tables because of the latency. They want to have quick reads, they want to have quick writes. And speed of light is what it is. You just can't move around the earth and give people that feeling of instantaneous action. But you were asking about the high availability disaster recovery. What that is, like I was saying, DynamoDB replicates to 3 AZs within a certain region, foundational technology and the AWS stack, very likely to be available for you, right, with even the 4 nines. But people say, maybe I need a 5 nines deployment, so therefore I need to be built on something 5 nines. And maybe they're worried about an issue that isn't just DynamoDB. What you don't do is you don't have a stack in region A that connects to DynamoDB in region A and say, but if that DynamoDB goes down, I will connect to DynamoDB in region B for my stack in region A. That's generally not best practice. For one thing, if DynamoDB is having any sort of bad weather day in region A, other things in region A will probably be affected as well because DynamoDB is so foundational. But also, you don't want your code in region A to be going cross-region for all of its actions. You generally want to route the user to the stack in region B where it connects to DynamoDB local there. So the way to think about it is, if anything is wrong, possibly I messed up my IAM, possibly I deployed the wrong code, possibly I don't know what's going on, but something is weird in region A. It's not just, there's a long list of things that could go wrong in A, but I have B. And when I deploy code in A, I don't also deploy in B. So therefore, if something goes wrong, I move to B. DynamoDB Global Tables ensures that the data in B is the same as the data in A, or quickly the same, right? We can have a deep conversation about the latencies that you deal with, but the speed of light is an issue. We don't do blocking writes. We take the write, and then after the write, we replicate to the other region, typically sub-second, but it is not in, speed of light doesn't let it be instantaneous, and we don't want to pause the writes until we've done the propagation to return the success. We'll take the write, make it durable, and then propagate asynchronously to the other regions.
So it's sort of a near real-time replication. You're still going to have your super fast local read and write latency, and then the second region is going to be slightly asynchronous, and at least you've got a very sub-second copy of your data.
Exactly. Some people say, what happens when you write to a global table? Is there a main region holding the truth and replicating to others? No, every region is an equal participant. If you do a write in one region, it will accept it and then propagate to the other. And it's always active-active. Now, this is where it gets interesting. And one reason that I'm here is that I've spent the last several months writing a prescriptive guidance guide to global tables. So Julian, maybe you'll share a link here as part of this, I'm sure, in the comments and whatnot, which is a deep dive on what does it mean how do I build a production application in an active environment, right? Because the first question that someone should ask is, what happens with conflicts, right? So I take a write, you take a write, it takes sub-second, but still some measurable time to replicate the items from one region to another. What if I write and you write at the same time to the same item? What do you think? What could you do? What DynamoDB does is a last writer wins mechanism. So everything's time stamped, and the one that came last wins, right? So if you write, I write, mine's a little later, I win. Same as a file system, basically. Okay, so it's active, but now I have to be somewhat careful sometimes as a result of that in making sure that I don't miss a write that happened in one region and that then quickly was written in the other one. So the short answer, and the paper dives deep, and we can dive deep today, is is be careful. Either have an application which is idempotent, like an append only data set. Well, that's just fine. You're not going to overwrite. Or maybe you in the application layer create, this is where I do writes. And that one doesn't take writes except when this one has an issue and I decide to change my write region. In which case, then I can do like transactions and conditional expressions and things like that that always have to work against the very latest data. Because in a eventually consistent model where I'm writing to multiple regions, I have to be sure that my write pattern supports that true active-active. And so one thing that I put in this paper is that there's kind of 3 write modes that people can do. One is true active-active, write to any region. And there's a wide variety of use cases for this. I'm going to insert idempotently some data. Every data item has its own unique GUID as an identifier. I'll never overwrite, so I can write here, I can write there, and there'll never be a conflict. I'm good. Or maybe, and you see this with like the streaming TV services, where every time you're watching TV and it remembers if your ratings, it remembers what your latest bookmark is for a thing. That's a perfect use case for, you can write to any region. You say that you're at this TV show at minute 5 and you're at minute 6, the last write should win. And it doesn't matter if you write to region A, B, C, D, you're always basically going to eventually get to the right answer. And if you read a little bit stale data, that's okay. And the paper has some interesting use cases where it's appropriate to be able to write to any region. And if you can write to any region, it's a wonderful deployment model because it's so easy to route requests because you don't have to be careful. But another write model is I'm going to write to one region. And in that case, I have to have something in my stack which will make sure that my writes go here. My reads maybe can go everywhere. It's up to you. Maybe you need strongly consistent reads that go to one region. Maybe you have eventually consistent reads that can go to any region. But I'm going to route my writes to this region until such time as maybe I move it to here. And some people do follow the sun, where it goes here and then it goes to this region, then it goes to that region as they go around the world where the main activity is. And that way everyone's getting low latency. So you do this, maybe you do this for high availability and disaster recovery, but maybe you do it because you want where the peak activity is to have the lowest writes, right? So if you're doing financial trades, when the US markets are open, you have the US be the place that you do your writes. And when Europe's open, you have Europe be the place, and Asia's open, you have Asia be the place where you do the writes. And then you do a follow the sun model of where the primary regions are.
So that's a sort of an architectural decision, but it's driven by having, you need the up-to-date writes. The reads can be eventually consistent in other regions, but you just basically pointing your application to one primary region, but that region can fail over even during the day or in a disaster recovery scenario or that kind of thing. But you just have a little bit more confidence that all writes are going to one place.
Right. And you have a couple of reasons why you might want to not do active-active. The DynamoDB table is active-active, but what you're doing is laying on top of that logic that says, sure, but I'm not going to use that. I'm always going to do my writes here. And you do that because maybe you want transactions. Well, you can do transactions in a global table and they're ACID in the region you write them to, but they propagate independently. So if you update 10 items, those 10 items will propagate but on their own lifespan, not as an ACID transaction on the receiving end. So you want to be careful about something like that, that if you want to do transactions, you probably want to do writes in one region. Maybe you want to do reads, your transactional reads out of that region as well, and have the other region around for backup should there be an issue with the primary. Another one is conditional expressions, where you want to say, hey, increment this, if this. Well, if you're going to have mutations in response to looking at the very latest version of the data, you need to be sure you're looking at the very latest version of the data. And so that's another reason that people might want to do a single region.
Some people are using Dynamo for even idempotency tokens and things like that, where that is your source of truth for idempotency. You do need to think there. Think about the recentness of your data. It's a terrible word, recentness, but
right. There's a replication latency metric that you can see, which looks at how things are going. And sometimes people would say, well, should I fail over if that grows? And the answer is it might grow and you don't know which region's the one causing the growth. Maybe it's my source, maybe it's my destination. I know it's slow, but I don't know why. So what you need to do in that case is set up other metrics. And I encourage people to do metrics that aren't only the DynamoDB metrics. You want to have your application instrumented, synthetic canaries that are watching and looking for, so I've got traffic in A and I've got traffic in B. How's it looking? Is A going well? Is B? Whichever region is looking like there are actual challenges, maybe I want to evacuate that region, go to the other region. Make sense? So it's less, I think, about let's make sure DynamoDB, because DynamoDB runs on thousands of servers as core infrastructure in an AWS region, right? It's not a server-oriented thing. It's serverless. Maybe we should promote that serverless word. It's serverless. You don't see the servers. And so you don't have to as much think, what if it's having issues? It's more, I'm going to use DynamoDB to replicate the data so that if for any reason I decide to move from one region to another, I can. Someone says if a secondary region has some issues and recovers after sometimes say an hour, what happens to replication during this hour, and will the data from primary get replicated? Yeah, no matter what happens, it's going to replicate bidirectionally. If one region is for any reason not replicating, when it comes back, the data it had before it went down, like let's say that you just took all the Eastern Seaboard down for power, and therefore, even if the region had battery backups, the network was impossible to get anything out of the whole Eastern Seaboard. Well, there were some writes that happened before that. They're going to wait. And there were some incoming writes that are happening as life goes on, and they're going to wait. And when it comes back, the eventual consistency, last writer wins mechanism will bring things back eventually to the same state in both regions. And that's the goal of things, is to be able to unify up at that point, which does create interesting challenges. So what do you do in that situation? And this is what the prescriptive guidance dives into. Is so I'm doing writes to maybe region A, and then for some reason region A is network severed from the rest of the world, and I've got a region B copy, but region B is maybe a second stale, and I've got data in A that will replicate out when A is network connected to the world again. But for a while I've just that's offline. What do we do? Or what do we do if A is maybe sluggish instead of severed? In any sort of distributed computing context, you wish things would easily sever. Those are the easiest ones to plan for. The hard ones is 50% works, and things are getting out, but not reliably. And so what you do in situations like this, you detect that, you decide I'm going to do my writes to the other one. And you decide, do I wait a little bit to let my writes propagate? Can I watch as they propagate over and decide, okay, now I'm caught up? Or can your business processes allow you to start actively writing to the secondary region, even while the other region maybe has some writes that are pending? And so it's a tough thing to just verbally explain because it's a very deep subject. But there are situations where you can say, well, I can detect which ones are a little bit stale. So maybe I will block and quarantine that data, so I won't accept new writes, because I know I have a partial view. So there's a financial services firm that needed this. And let's say that you have a second gap should the region be severed from the internet. Well, if it's social media, you probably just truck on forward. You lost a second of posts, it'll be all right. If it's financial, it's a bigger deal. Maybe that one item was the $44 billion purchase of Twitter. Want to make sure that we caught that and that we don't let someone double spend that 44 billion. So in that case, and I can dive a little bit, like one design pattern is that you have a third region C, where before you take the write into region A, you go to this one and you say, by the way, I'm about to do a write here, so kind of lock this. It had 5 transactions, it's going to have 7. And C says, got it, that account will have 7 transactions. Then you do those transactions in A, add 6 and 7. And then the secondary region B is getting the replications from A. But should there ever be a time where we decide, oh, A is off or A is sluggish, B can look at C to get a sense, does it have the very latest data for that account? Because it can say, see, this account, how many transactions should it have? 7? Do I have 7? If so, I'm good, and I can proceed because I know there's nothing pending. If I see 6, I say, oh, I know this account is partial. Now, maybe A was severed before it even took the writes. You don't know. But you're going to err on the side of someone was intending to move me to 7. So I'm going to say you are quarantined as an account until such time as I get your full data. And in a financial services context, what's the fraction of accounts that during a 1-second period have any mutations? Very low, right? So 99.99 accounts are just fine. They don't know. And there's those few that say, please call your service representative right now while we wait for Region 8 to give us the very latest data, because we know you did it right, or we're trying to, and we're going to wait until we get the right. So that's another thing that you build on top of global tables to be able to have some sort of sense of, am I fully caught up?
So should people think of global tables as this very robust replication mechanism underneath the hood, which is just going to pretty much carry on regardless, and you can build some checks and balances above that to make sure that writes have happened in various regions, and cleverly use the simplicity of global tables to just replicate data, not turn it on and off, not go through all this hairy checking kind of thing, and just make sure that assume that DynamoDB is eventually going to catch up, but write your application for that, depending on how strictly you need up-to-date information.
I'd say that's pretty accurate. And so the thing that I encourage in the paper is that you understand your write mode. And there's really 3 write modes. I've kind of covered 2. One is I'm going to embrace the eventual consistency, and it's okay with my data model. These streaming service, bookmarking, ratings. You rate the movie, you rate it an A. If A's not propagating to B, it takes a while for your rating to show up. It's all right. Another one is that you have that right to one region, which we covered because you need transactions or whatnot. And then the more interesting, complicated one is that you have right to your region. And in this situation, data items are homed to a particular region. So yours is near you and mine is near me. And you have something that is being able to track, where data is homed. And we make sure that you only write near you and I only write near me, but that I'm now writing to both regions, but in a selective manner. And that's great because you and I, even though we're separated by large geographic distance, can have very quick reads and writes, very quick writes because we're going to the local region, and very quick, strongly consistent reads because I'm able to do a local read that's actually has the very latest data, right? So this is a good thing. Now the challenge there is, how do I, with 1 trillion items in my table, figure out where data is homed? And I encourage you again to read a paper that dives into this in some depth. There's a few different ways to do it. Sometimes people put an attribute on the item that says where it is, and if you try to read or write to a different one, you can look at that attribute and say, oh, I'm in the wrong place. Another one actually that's pretty simple to understand is that I would have 2 global tables. I would have a global table that has a primary here and a global table that has a primary there. And I know that I go against this table and you go against that table. And each table only allows the writes from the nearby region until there's an event where I have to do an evacuation, in which case I'm saying, okay, now this table can be written from the other region. And so in that case, you've isolated the data sets by name. So like a table which says I am homed in USA and a table I am homed in EU, they're both replicating to a copy of themselves to the other region, but now I've got 2 different table names, each of which has 2 regions and half the data. And that works if you don't rehome people too often.
So that's in a way going back to the second option you had, which was the right to one region mode, but you're actually just splitting into separate tables to represent each different region.
Right. And sometimes it's in the item, like a financial services firm needed to track balances on credit cards. And so the challenge there is, if you're charging in the US, you should write to the US. If you're charging in the EU, I should write to the EU. I need low latency reads and writes. But how do I decrement a balance reliably when I have, I could write to either region. If you happen to charge at the same time in both regions, I could update the same item at the same time, and therefore the conflict of last writer wins, I would miss a decrement. So what do? Maybe I'll let people ponder that for a second. But the answer that we came up with was kind of interesting, which was you split the balance into 2 halves. And so you have a US balance and an EU balance. And when you do a charge in the US, we decrement the US. And when we do a charge in the EU, we decrement the EU. All right. And if the US is offline, you can still keep charging in the EU because you're going against the EU balance. A US action could go against the EU table, but it would decrement the EU balance. And in general, people aren't up close against their balance limits. So you're pretty good. You have 10,000, you split it 5,000, 5,000, and you go to town. And in that case, even if it's maybe the one table, I know that there's a US item and an EU item. And I always write the US one in the US and the EU one in the EU unless special cases. But that's, I thought, an interesting design point. As part of writing this paper, I interviewed a lot of people to say, how do you solve this challenge? Because the basics of global tables are, I think, quite straightforward. It's kind of like, checkers. The rules are pretty straightforward. The interesting part is how do you reliably win at checkers? And that's what I'm trying to provide here. Do we have other questions I should look at?
Yeah, we do. We just, well, when we're just talking about, Velson4, thanks for joining us via Twitch. When the replication happens, does things like condition expression and so on are applied to the replicated region, or the whole item is replicated directly?
Yeah, it applies only to the region where it's written. The condition is, because how else could it work, right? So how it works underneath, that condition is applied, and if it accepts the write, it accepts the write. At that point, it streams out. So the same way that you can do triggers with your own Lambda, that system is used, and then there's a system that sees the event and will propagate it over the wire to the remote regions that are participating in the global table. It's invisible to you, but that's what's happening underneath. There's a system watching those mutations, and at that point, it's just going to be going in. There is an implicit conditional expression on the receiving end that says, write this, unless you have something newer. And that's the last writer wins mechanism, right? So if I'm writing at timestamp X and you have X plus 1, I'm going to fail. And that's the last writer wins in practice.
Okay, thanks. And Moen, yeah, thanks for your questions before as well from YouTube. Well, so I suppose if you had to set up global tables from scratch or with existing data, will old data from tables in one region copy to another region when we enable on existing tables?
Yeah, it's great. There's two versions of global tables, the 2017, the 2019. The nice part, you should use 2019, more affordable and more featureful. But one of the nice things 2019 has, 2017 didn't, is that you can have an existing table and say, I'd like to have a replica over there, and it says right on it. And it does basically an implicit backup restore type thing to get the data going in the other table, and then it hooks up the replication, and then you're good to go. So you can do that as even to existing tables. You have to be a little careful with CloudFormation because it's a different resource type. So the paper talks a little bit about that, but at least at the, with the console, you can say make a global table. And you can actually, with this, migrate your data. So say you had everything in one region and you said, my whole stack needs to be in another region. You can use global tables to live move a copy of the data to the other region, and then detach and delete the first region. And now you've just seamlessly moved your data from A to B without having to stop action. That's another use case that people will use global tables for.
Cool. So we've spoken about the write modes, but I know also the paper's got a lot on sort of routing strategies of where you even send your writes to. So yeah, do you want to? I know you've covered some of them, but yeah, can you go through some of that, please?
Yeah, because that's the next challenge. So I encourage people to first identify your write mode. If you have the write to any, then life gets easier. But if you're saying, I'm going to do write to your region, now you have to be more careful. So the paper introduces 4 routing strategies. The first one is client-driven, which I'm a bigger fan of than you might think. The idea is that let the client know the endpoints and let the client choose which one to talk to, as opposed to trying to invisibly make it something that the client doesn't need to participate in. You expressly tell the client, so you are a video streaming service, and I'm going to tell you that I have an endpoint here and here and here, and I'll let you decide which one to hit. And you can do that by pinging them and seeing which one's lowest latency. You can do a little bandwidth test and see which one you're best connected to for any sort of purpose. And if you start to have glitches for any reason, it could, who knows why, it's not necessarily a glitch that's within the AWS infrastructure. It could be between you and the endpoint. You get the choice to say, I've changed my mind and I'm going to this endpoint. And because endpoints aren't brought up all that often, right? It's not every day that you say, I've created a new region for a client to connect to. You can push that decision-making to the client. And for use cases like the write to any region, it's real straightforward. With a write to one region, the client can say, so who's live right now? I'll talk to them. I'll do reads, but maybe I do a ping, or maybe I just try. Well, this one's close. Oh, it didn't take my write. How about this one? Will it take my write? Oh, it does. All right, I'll go there. And in this case, you have full control. And I think you don't see this talked about as much as I think it deserves. I'm not saying it's right for every case, but I think that there's more to that than people often give it credit for.
No, definitely. I mean, I worked in financial companies before, and pushing that that decision making to edge devices. I mean, even things like DNS, you configure 2 DNS entries on an endpoint, and it's just going to pick the DNS entry that replies and work with that. Low networking kind of things. You have 2 DHCP servers, it's just going to pick one and respond from that. So I think that actually simplifies things a lot when the client can just take that control. It means you don't have to assume what's happening between the client and the server. The client can just make those decisions. Yeah.
Right. And Route 53 or other DNS is another choice. The idea being there that I connect to my write endpoint. Maybe I have a read and a write DNS entry, because sometimes reads can be to anyone and writes have to be limited. Sometimes people say I need to read from the same one, but a lot of times I can write to one and read from any. So I have a DNS, and the DNS can choose where you go. And that works pretty well. I get a little nervous using DNS alone to limit the writes to one region, because if I have to evacuate it and move to another region, I don't want DNS propagation and TTLs to participate in deciding where the writes go. I feel like there has to be a gating verification closer to the data that says, I know you have a stale DNS IP address, or you're just hitting an IP address that you remembered, and maybe your browser cached it, but you're not allowed to write here today. Thank you for trying, something like that. And please try again or whatnot. But then with DNS, you have to wait for the TTL, 60 seconds. It could take a long time, as opposed to a client-driven hit. But it is nice in some situations where you say, I'm going to use DNS. It's nice for the write to any region, because then I can just say, give me my write endpoint, and it will, based on whatever rules you want in Route 53, say, here's one, and you use that, and it's invisible to you. And that invisibility is really great. But when it starts to be write to your region as a write mode DNS, and that is really tricky. Like, how does DNS know where you are supposed to go for your data? And you start to need something more complex, like one customer uses a login mechanism. So you basically go to a globally distributed login, and you say, I'd like to do some writing of data. And it says, cool, here are your credentials, and here's your endpoint. And those credentials only work at that endpoint, so you can't route around it. And it's refreshed every 20 minutes. So the token's good for 20 minutes, after which you say, hey, I'd like to try again. And at that point, it could say, we're following the sun, now you're over here. And it makes sure that data where you were writing to one region is in the other region before it gives you the login. Maybe it makes you wait 10 seconds to make sure that it's replicated over, something like that. But that's one way to, even though I have many different clients and maybe I'm doing it with DNS, you just get an IP address and a token or something. You can also use Global Accelerator, which is very similar to Route 53 in that you ask for a well-known name, you get the IP address, a static IP address that goes to some edge node that routes to the eventual backend. Works great for the write to any region. Trickier for write to one region, although you could make it work, because you could configure Global Accelerator to say everything's going here for writes, or for like the write DNS name, and then maybe it'll go over there. And you have more control there than with DNS, because you don't have the TTL that you have to worry about. There's no client point of view in that. The entire routing happens within the AWS network. So I like that for a rapid adjustment of my topology. That when you do things like this, you do want to be aware. You want to do failovers using only data plane operations if you can, no control plane operations. That's just good advice in general. So you want to be able to make a decision like this where you don't have to do any sort of, hey, I changed the control plane. You want to have it do like a health check failure that says this one's no longer right, therefore I'm going to route over to here and I'll stay in the data plane zone. The other way to do routing, the fourth one that I talk about in the paper, is a compute layer, which is fairly complicated but powerful. The idea is that the client maybe connects the end client, wherever that is, connects to some compute layer that runs outside DynamoDB, and that compute layer is able to know who the primary write region is. So this is useful for the write to one region. If you're doing write to any region as a write mode, life is so much simpler, because it's like, hey, anyone will do. You don't have to be selective. But if you're doing write to one or write to your region, you have to be more careful. And so that compute layer can participate in a quorum-based system that knows who's the writer now. And if it knows that you want to do a write, but it's not the writer, it might be able to pass the message to another copy of itself in another region and say, hey, I've got someone here who wants to do this write. Could you do it? And the other region says, yeah, I got that for you. And so now at the nearest shell to the data in the architecture is where the enforcement happens, and also maybe some message passing. I discourage people from saying, let me in my code directly hit the endpoint.
Yeah.
And the reason is this, when you're doing a global quorum-based state, it can be tough to be sure you're right. And so something that can happen is my compute layer thinks that that's the primary, so I pass the message to that one, and that one says, you thought it was me? I don't think so. And you need to be able to catch that. Otherwise, you have the issue of writing to one you're not supposed to write to. So, there's a good story and a link in the paper, Vanguard, talking about doing this with a link to their reInvent talk 2022, which I thought was really an interesting, robust design where it's done at the compute layer. And you can mix and match these a little bit. Like you can have Route 53 send end users to the right stack, the regional stack, but then you can maybe have the compute layer verify, do we still think that we are the primary write mode? What I think is interesting about this, if you step back, is that DynamoDB's global tables is pretty straightforward and simple, right? Like write to any region you'd like, last writer wins. Very low latency replication. But then you say, okay, but I want to do transactions, but I need conditional, but I always need to read my own writes. But some cases where I can't do the write to any region, and so then you outside of global tables figure out how to route the data appropriately.
Cool. Yes, I posted a link to that Vanguard talk, which is super useful. So, and I suppose that compute layer request routing is also linked back to what you said before. Is don't write across regions from your actual client. That was one of the first things you said. So instead of writing directly to the DynamoDB secondary region, you're passing it to compute, who's then writing to its primary region, which keeps it a little bit less messy potentially.
Yeah, and I think I'll say again that if you talk to people, there's a temptation to have that stack in one region, and that you start thinking about global tables to make DynamoDB more HA. And it does. It goes from 4 nines to 5 nines, but that they still think I'll use that stack in A to connect remotely to DynamoDB in B. That's discouraged. You should generally have every stack in a region talk to its local endpoint. There is no global endpoint. We never will say, hey, we'll talk to one. You always know which region you're talking to. But if you start to see issues for any reason in stack A, kind of start routing end users to the stack in B and let them hit the DynamoDB in region B. And just trust DynamoDB global tables to keep that data synchronized so that as you change activity from one to another, it'll be there when you need it. And that's the idea. Sometimes you have a stack in both. If I'm doing write to one region, I tend to have more of a stack built up in the primary region, which means I have to maybe bring up more resources if I do an evacuation. If I'm doing write to your region, I have a little bit more built up. I talked to one customer that used 3 regions. Why? I thought, well, that's interesting. Why 3? 2 should do. And they said, well, that way that they have an easier time to have enough built up that should one fail, they have only each of the other 2 regions has to increase by 50% as much. So it's a little bit more of a, you can immediately take your reads and writes. The paper has a lot of discussion about things to be aware of, caveats, like make sure that you have your read and write scaling limits, either in auto scaling or at the table level or at the account level, sufficient that if suddenly all the writes that were going, mostly the reads really, if all the reads that were going to this one, suddenly all the reads of all the regions go to this one, that it can scale there.
Yeah.
Nice part about DynamoDB, it'll scale up, but you have to have your limits and your auto scaling. You can't have an auto scaling that maxes out at 10,000 because that's your usual traffic if suddenly traffic from other regions are coming in. Writes tend to be the same across every region, as makes sense, right? Because I take the write, I have to replicate it everywhere. With one caveat that I'll say, and which is TTL, right? TTL is time to live. And in TTL, the idea is that when you insert an item or update an item, you can have a TTL attribute that's the time that item can be removed. And after that time, not necessarily immediately, but like usually within 48 hours of that time, that item will be background deleted without charge to you. So that's kind of handy, right? With global tables, the TTL delete is no charge, but the propagated delete, that's still taking up a write unit, a replicated write unit, because we want the 2 tables to be in sync. We don't want TTL to delete here, and then tomorrow TTL to delete here. We want these two to be very much in sync. So one of the regions will TTL without a charge. The propagation will incur a charge. So you might have unbalanced writes. That's the one situation you tend to have unbalanced writes. Or like if you have a lot of conditional expression failures, you spend all day failing. Well, those will be writes charged to one region that don't actually propagate because you didn't do it right. So I've seen this sometimes. You look at the global table and you see this region's taking way more writes than the other one. They don't have TTL enabled. What would it be? Well, failed writes would do it because you still have to pay for that. Reads tend to be unbalanced, and we expect reads to be unbalanced. But like I say, you want to set up your auto scaling or in an on-demand table your limits to be able to execute the failover scenario where maybe the reads were distributed across many regions, and now they're all going to maybe one region.
So just you alluded, what does the pricing mechanism work for this?
Right. So first how does it work for DynamoDB, right? DynamoDB in on-demand mode, you pay by the requests. So you have read request units and write request units. And it depends on how many and how big. And then in global tables, there are replicated write request units and replicated write capacity units. Reads are the same because you just read. You read from a local table. There's nothing interesting. Replication, there's no charge except for the data transfer, like for the fact that we're doing this background streams work and keeping things in sync. But instead of write request units and write capacity units, you incur replicated write request units and replicated write capacity units. Say that fast. It's hard. And those, it depends on the region, but they're a 50% uplift from a normal write request unit or write capacity unit. So that covers the infrastructure. That's how the cost is presented, is that instead of regular ones, you get these replicated. Now, something to be aware of, things like if you've purchased reserved capacity, that works for WCUs, doesn't work for our WCUs, the replicated write capacity units. So you have to be aware of that if you're thinking global tables in the context of having reserved capacity. Other things like standard infrequent access storage type, changes things, and that interaction with global tables a little different as well. So that's how pricing works on it.
So what's also actually the process for failing over? How do you move from one table? How do you move from one region from a global table to another? We've talked a lot about the architectural patterns that would sit on top of your application to decide that. But is it right-click failover? What are we talking about?
Yeah, and what's interesting about that question is you don't have to tell DynamoDB anything because DynamoDB is always active at its level, right? You don't have to say like, hey, you're no longer, you are, and you guys, no. All that happens is you change your behavior of interaction with your regional endpoints. So, in a write to any region, write mode, you just send more traffic or all traffic to another region. A is having issues. I stop writing to A. I write to B and C. And I failed over. The A data is replicated over. If it's write to one region and the one that you're evacuating is the primary region, well, now you've got to, and in the infrastructure, say, all right, quiesce the writes over here. We don't want to take any more writes. Let them propagate. And then, all right, now we're ready to start writing over here. And there's not a signal that says you're fully replicated, but people tend to wait enough time. If they say my usual replication latency has been half a second, I wait 5 seconds or 10 seconds. I'm like, all right, and then they start writing to the other one. Like I say, if the reason for the evacuation is that the first region is no longer replicating, well, now you've said, well, I'm going to start taking writes in the second region, or I'm going to start sending writes to the second region, but I know I'm missing some data. So it's a business decision what you do about the fact that some data is missing. If it's right to your region, then you have to figure out, how do I effectively mark that while Julian was in East Coast, Julian is now in West Coast. And that's DynamoDB doesn't really have an opinion about that. That is entirely done in your stack of how do you decide to route your traffic and how do you make sure that this person goes there. If you do it in like an attribute, then it's a little tricky because I kind of have to update you. I have to update all your items with that attribute. So maybe I want to do something more like you connect in and do a query and say, so where should I go? And then when I decide to block you, you say, well, that was interesting. Hey, central service, could you tell me where to go now? And we say, yes, Julian, you now are here. Or maybe I say, we're still replicating, try back in 5 seconds. I'm not convinced that your data is accurate in the second region, so hold on. Everyone else is still going, but maybe I don't let you get an endpoint. Maybe don't give you a token for a little bit. So there's not a DynamoDB button to push. It's entirely on your stack. And like I said before, I encourage you to have synthetic canaries, something that is watching to see how are things going, to be watching real live user interactions. You can look at DynamoDB metrics, but they may look fine. Maybe the issue is not DynamoDB. The reason to evacuate a region, I'd say probably the minority of the time, would be something actually about DynamoDB, and more like, I've got a glitch in my component X because we are so, DynamoDB is what, 11 years old now, roughly. It's a very mature product, designed to support Amazon.com. When you put an item in your shopping cart, DynamoDB is there. How often has that failed, right? That stuff works. And so that stuff's very solid. But maybe I want to leave for other reasons. Maybe I want to leave because I don't understand what's going wrong in A, but I know that B is working. So thank you, DynamoDB, for having a copy of my data in B. And I'm going to move the rest of my processing over to B. I recognize that sometimes the stack around DynamoDB takes time to set up or incurs a cost, but that's a separate issue I link to in the paper about Pilot Light and warm standbys and the mechanisms for that. The role of DynamoDB is to keep the data there when you're ready to have it there.
Yeah, I mean, that's if you've got this 5 nines requirement, you're going to need another stack and some other compute in region B. You're not just turning on global tables and magic and unicorns is just going to happen. You're going to need something else because I mean, as you say, it could be a deployment issue, it could be an IAM permission that's gone wrong, or a security group that somebody's updated that's caused a disconnect from your Lambda function or your EC2 instance.
Yeah, I always worry about that. Some sort of push button IAM. It's good advice to have different roles in the regions so that you don't have the ability to hurt 2 regions at the same time.
Okay. Well, I mean, that's why AWS we have very strict boundaries between our own regions. You do want to have, different CI/CD pipelines, different, as many things as you can to sort of not air gap, but differentiate your regions from your application as much as possible.
Right. Other things I feel like educating, streams will process on both sides because they're writes. Any place the write happens, it propagates. So be aware of that. If you want to have streams only on one, you basically have to add an attribute yourself that says I am in region X. And then the one that is not can be event filtered away to say, oh, I'm not in X, which works well for any writes, but not for deletes. For deletes, it's trickier because it's kind of going to be double processed. I'll let you know if I find a great way. If you're using DAX is the DynamoDB accelerator cache, and global tables right around DAX. They don't go through DAX, which means that if you have an item cache in DAX with like a 5-minute TTL, it's not going to know that some data items came in from the remote region through global tables until the TTL expires and it refreshes it. So that's another reason you might start thinking, well, maybe I want to use this right to one region or right to your region, because if you're using DAX with right to any region, your cache will not see the writes until it pulls them again off the disk. Sometimes people ask, where should I do backups? And it depends on why you're doing the backups, but on-demand backups are generally to keep a copy of the data as of a time point, for like regulatory purposes. And so those you can do in one region. Maybe afterwards you can write them to another region. I'm going to do a backup here and then maybe copy it for resiliency or something. But you don't need to necessarily back up in more. Pitter, same kind of thing. You can turn that on in one region. Pitter is point-in-time recovery. The idea being, I want to be able to make a mistake in my application code or as an admin or something and have deleted items or changed items and say, could I undo that? And so this point-in-time recovery lets you recover the table as it was in the past. Generally, that's okay in one region. So things like that, it can reduce your cost.
Yeah, and the Merm says there are only two things that are difficult in computer science: cache invalidation and naming things.
Yes. Yes.
Thank you, the Merms. Perfect.
So yeah, I'd love to hear. We have about 5 minutes. If people have other questions, there's a comment.
Yeah, send us if you have any questions. Questions you have. Yeah, and also just from the checklist, there's all from the prescriptive guidance. There's also a handy checklist which has gone through a whole lot of things Jason has been talking about some of the metrics you need to do. Talking about the write modes. So recapping the write modes we need to think about, the routing strategies, the evacuation plan. Some super useful information over there. So yeah, this is actually a really well written prescriptive guidance. The point being prescriptive. So I know a lot of AWS has lots of different ways to do things. This is super useful information that is literally the prescriptive way of this is the good way to do it.
With a lot of great stories from people and what they did, because I was really fascinated by and especially with people who got on stage at reInvent and talked about their architecture. So there's links to those videos, and so you can see how, especially in financial services firms, which have some of the strictest standards needed for keeping every data item and never letting something be dropping through the cracks. How do you maintain that on a last writer wins mechanism? Because last writer wins could be seen as, but I don't want that to ever happen, right? So how do I design an architecture where I never have that eventuality, or at least never where I was worried that it might happen? One of the stories in there is an ad tech company that uses an item for you. So when you come in, they show you an ad, and they have one item for the ads that you've seen lately, and it's a list. And so they get the item and they decide what to show you, and then they cut the first ones off the list and append the new ads to the back and insert that item again. And that way they just have kind of an LRU of the ads you've seen. And they were able to go with the right to any region because they made the strategic decision that, you know what, if you see an ad in two regions at the same time, I'm going to forget one of the ads I showed you. All that's going to happen is you're going to be a little annoyed that you're going to see the same mattress ad twice. Not worth the complexity of making sure that I never forget that I showed you a mattress ad. So one of the things in the prescriptive guidance is, can you design an architecture where things are idempotent, where you can write to any region? If so, all the routing strategies are easy, the evacuation strategies are easy. Or do you need a single region, which, is probably simpler than the write to your region, because the downside of the write to one is, well, the writes are going to have to go across the world. So they're going to be slower, but maybe you'll have the reads nearby, but they'll be eventually consistent reads. Is that okay with your architecture? Or do you do the write to your, where it's kind of like having everybody has their own local copy, but I've got another secondary copy in case of a challenge, in case of an issue. So that's what the paper talks about.
Excellent. It's a super well done paper. Thank you very much. Just before we do say goodbye to Jason, same time, same place next week, we're talking serverless observability with Slickwatch. This is a partner called Four Theorem with Owen Shanahy and Diran Akok, who are going to be talking about that. Super exciting. And then serverlessland.com, I just did mention everything to do with serverless on AWS, lots of learning guides, content, lots of code. So in fact, if you're building DynamoDB applications and you want to see how you can integrate in the SAM templates or Pulumi or Terraform or CDK or in literally any kind of language, you can look at the serverless patterns. This was the learn page. I'll jump back to that. I'm going mad. Serverless patterns, say s12d.com/patterns. Yeah, loads of DynamoDB patterns to be able to look at and get going with DynamoDB. And then I did mention EDA Day, Nashville, 26th of October, 2023. Would absolutely love to see you there. Well, Jason, phenomenal deep dive into DynamoDB global tables. We've been going for literally an hour of nothing but all the synchronized across the world. So yeah, super useful information. I will just do the link to the prescriptive guidance again, because that is super useful, very well written. I know one of the challenges of these is actually to have all the information over there, but not get so into the weeds that it's impenetrable to understand. So diagrams are simple, the language is simple, it's got great use cases and links to other videos and that kind of thing. So yeah, good job, and thank you very much for coming on Serverless Office Hours.
It's been great.
Excellent. Thank you very much, Jason.
Bye.